Let's focus on one of the most common errors in pipelined ADCs, which is called comparator offset. Inside each stage of our pipeline, there's a small flash ADC, and that flash ADC is built from comparators. In an ideal world, a comparator would switch its output at exactly the reference threshold voltage. However, due to tiny imperfections in the manufacturing process, real-world comparators have a small error voltage built in. This is the offset. It means the comparator might switch a little too early or a little too late. So, what's the big deal? Well, if the comparator makes a wrong decision because of this offset, the sub-ADC produces the wrong digital output for that stage. This wrong digital code is then fed into the sub-DAC, which in turn subtracts the wrong analog value from the input signal. This creates an error in the residue voltage, the V-unders, that gets passed to the next stage. Now, look at the graph on the right. This shows the residue voltage on the y-axis versus the input voltage on the x-axis. The ideal behavior is a perfect sawtooth wave that stays within the range of positive V_R and negative V_. This range is critical because it's the maximum input the next stage in the pipeline is designed to handle. But with comparator offset, the error in the residue can cause it to exceed this range. Look at the red circles. The residue voltage tries to go higher than plus V_ or lower than V_. When this happens, the amplifier in the next stage gets completely overwhelmed and saturates. It's like trying to shout into a microphone that has a volume limit. Any sound above that limit just gets clipped off. This clipping is a major problem. This leads to two serious consequences. The first is missing levels, highlighted by the red circles. Because the residue voltage is clipped, certain analog values are simply lost. They never get created and passed down the pipeline. You've lost that piece of information forever. The second and even more critical problem is missing codes, shown by the purple circles. When all the digital bits from all the stages are combined at the end, these missing levels result in gaps in the final digital output. The ADC will never be able to produce certain digital codes. This is a huge issue for the overall accuracy and linearity of the converter. So, it sounds like comparator offset can be a fatal flaw. But fortunately, there's a very clever way to fix this. As the slide says, redundancy can overcome this. We can design our ADC stages to have some extra room, some tolerance, so that even if the residue voltage is a little bit off, it doesn't saturate the next stage. We'll explore exactly how this redundancy works next.